and practice here. The thing with domain and range is we've kind of talked through most of it at this point. And now it's just about practice, being able to practice it, see all the different ways, understand the different notations, and then go from there, okay? So here's what we got today. We actually have pushed our tests back a day. So we're going to focus, again, one more full day on domain and range, try to get all of our Delta Math done, take a check for understanding at the end, kind of see how we do, and then that gives us a full day of review on Friday for you guys. And then we'll have the test next week on Tuesday and Wednesday for B-Day. So that's what we're doing. That's the plan. So we'll come back to if you need to have your Chromebook on a charger. We're going to be using those, but not right now. So close them up. If you need to charge them, find an outlet, and we'll go from there. Okay? All right, y'all ready to knock this out? Okay, so as a reminder, because again, we kind of already tackled discrete. We're going to jump into continuous here. Here's our notation. We put our boundaries for our domain. We always kind of set it up with a less than, an X, and a less than sign. And then X is in the middle because it's domain, and domain's always talking about what X values are happening. Range is the same thing, but we put a Y in there because Y values are what we're talking about with range. And then we put in our boundaries, our left boundary to our right boundary for domain, our bottom to our top with range. So that's kind of our setup. Then we have to go through and look at, okay, do I have closed dots or open dots? Do I have arrows? And that kind of determines if we need to give these guys equal tos or not. So we did some Delta Math on that, and I think that was helpful. I might have y'all do a little bit more of that when we practice. But let's see what we skipped. It looks like we skipped this one right here. So on page 9, we'll look at that one, and we'll do this one together as a warm-up. And then I'm going to have y'all try another graph on there, okay? Can we agree that this is continuous? Yes or no? Yes. Why? Because it's connected. So this is a continuous graph because it's connected. Doesn't necessarily matter. Sometimes people say continuous, it has to go on forever. It can, but as long as you have connected between points, then it still falls under that continuous umbrella. And so our setup for our domain, we're going to have our little template here, less than X, less than. What goes with the range? Less than Y, less than. Okay? And then I'm going to go in and I'm going to put in those boundaries. So can I put a boundary on the left? Can you draw in a boundary on the left of this graph right here? Yes or no? Can you do it? Get your pencil. Do it. Right there. I can find the leftmost point. Okay? And what X value did I draw through? -4. So what goes in this first blank? -4. Now, at -4, I have a closed circle. They took the extra ink to color it in, so what do I have to do right here? Draw a line under it. Okay? What's your right boundary going to be? Do you have one? 2. And then I need to put a little line under it. All right? For the range, remember with range is bottom to top, and you're talking about Y values. So I'm looking at this Y axis here. So I'm drawing my boundary. My Y value, what was my lowest Y value? 1, 2, 3. -3, and again a closed circle. And then my highest Y value, +3. Very good. Closed circle there.
Where did you get -4 from?
Our X value right here that we cut through was 1, 2, 3, -4. I really think drawing on the graph like I'm doing, kind of putting your graph in a little picture frame like that, will really help you. If you just go, if you're not doing that, I really suggest it. And if you want a highlighter, I'll give you a highlighter, okay? But I think that's helpful just to, like I said, get a little picture frame around what's going on, and that helps you see your boundaries one at a time here. Let's try this circle over here, this graph, and then we're going to jump into the word problems. First of all, is this guy a function, this circle right here? No. Why not?
Because it goes through the line twice.
It fails the vertical line test. So you can still find domain and range of something that is not a function, and we're going to do that right there. Is this circle continuous? Is it connected?
Yes.
Yeah, it's not a graph of dots, so this is going to be continuous. So we will do our domain and range setup for continuous. Domain, range, less than x, less than y, less than. Now, there's no open or closed circles on here, but remember, what did I say last time? If there's not a defined open circle and it just looks like it touches, we're going to assume that it equals, right? But we're just making that assumption because there's not an open circle and there's not an arrow, okay? All right, you guys try this one. Bound it off. Draw a picture frame around it. And then put in your boundaries in the inequality. Looks like you guys are getting some answers here. So our domain, again, I put my boundaries in for my left and my right. What's my leftmost x value? Negative 2. And again, we assume that the graph is touching, so it equals there. What about my rightmost x value? 2. And again, assume that it equals there. What about range? Y values. It's the bottom. 0, 2, 4. And then these both equal. Okay? So let's talk about in words what this means. So I'm going to show you on the back with some of the problems, with one of them, a way that you can write these statements in words, because the STAR test sometimes does that. And so I really want you to understand what this notation is saying. So let's just focus right here on this guy. Okay, here's how you would read that. And again, I want you to understand what you're reading and what it's actually saying, because I think that will kind of help it all click there. So what I circled, the domain, we looking at that? Okay, if we read this left to right, this says negative 2 is less than or equal to x is less than or equal to 2. And we can all agree that these numbers that we put right there are your boundaries. But what that inequality is saying is my x values are in between those two numbers, okay? So x values that are bigger than negative 2 or smaller than positive 2. That's what that inequality means, and that's why we use that notation. And I just want you to kind of be able to interpret that, because I've got some multiple choice questions on your Delta Math, and sometimes they do that. They will write, like literally in words, the domain is all x values greater than negative 2 and less than positive 2. And so I don't want you to get to a multiple choice question on the STAR test and be like, whoa, I can't do it because it doesn't look like this. I want you to be able to interpret that there, okay? So we're going to practice that on the back. But before we do that, I want to try some word problems, okay? And the word problems can sometimes be tricky. You're going to have some word problems on your test. So let's do the first one together. I'm going to let you guys try the next one. Are you with me? Yep. Are we awake and ready? Yes, yes, yes. I need you to be awake and ready. Okay, what's our situation? Coach Soares, or Coach Holt too. Well, I guess we can give you a shout out because you're in here. Coach Soares is the girls' assistant soccer coach. But she's driving the soccer team to Georgetown for the state championship. Okay, driving the bus. The bus holds 150 gallons of gas. The bus can drive 6 miles per gallon. Write the reasonable domain and range for the situation. And I just want you to know that we were Googling how much a bus can hold and the miles per gallon. So these are accurate numbers, just so you know, okay? Because sometimes your math problems are not accurate here. So the first thing that I want us to do is I want us to go through and think about the situation and say, is this going to be a discrete or continuous? That's like step 1. So we're talking about driving, okay? We're driving the bus. And we're talking about distance. If you might want to look back, distance is going to be what type of situation? Discrete or continuous? It's going to be continuous, okay? Because you're driving all those miles. You're covering every single decimal from here to Georgetown, okay? Unlike something that would be discrete, which means you can only go like 1 mile, 2 miles, 3 miles. We can go whatever, okay? So this is going to be a continuous situation. So I'm going to write that at the top because that's going to determine how I set my stuff up. So let's do domain. Let's do range. I'm going to go ahead and get my template set up for continuous. But then I got to figure out, okay, what is my domain going to be talking about? I know it's X, but in this story, what does X represent? And the same thing with the range. Go ahead. Do you need to sharpen? Oh, it's not plugged in. Okay? So, well, hold on. I would write an equation for these, okay? So let's say the bus holds 150 gallons of gas. That's important. The bus can drive 6 miles per gallon, okay? So how would I write an equation for that? Y is equal to an equation with a variable. Y is equal to
I have no idea.
miles per gallon. What? 6x. Okay? So when you see that word per, that's kind of telling you, hey, this is per needs to have a variable next to it. So what does x represent per gallon?
6 miles per gallon.
Well, that's a 6, but x represents the
Per gallon.
gallons. Okay? Go ahead. And y, you good?
No.
Okay. Is going to represent the miles. So however many gallons of gas we have, we know we can go 6 times that. We can drive that many miles, okay? So you really want to know what X represents and what Y represents. It's kind of tricky. So I always think going back to the equation is going to make a little bit more sense. So let's talk about domain. So domain is talking about our X's, which is our gallons. So what's the least amount of gallons that we can have on the bus? Gallons of gas.
6.
1.
Can you be empty? That's the
0.
most. What's the least?
0.
0. You can have no gas. You're out of gas. Not in a good place. So 0 is the least amount of gas we can have. We can be at exactly 0. We shouldn't be, because we need to be better drivers than that. But we could have 0 gas.
And the next one's 150.
How did you know the upper boundary is 150?
Because it says it holds 150.
Because it says that in the problem. The holds 150 gallons of gas. So that's the most amount we can have. So this is representing, hey, what's the possibility of gallons of gas we can have on the bus? And that's our domain. And we're done with domain. Are we okay with that? But we had to interpret that gallons is talking about, or X is talking about the possibility of how many gallons of gas we can hold. So range is going to talk about how many miles we can
So
drive.
do 6 times 150.
You
Should
do.
be 900.
Okay? All right, I want you to explain that in just a second. What's the least? We're going to do the least first. What's the least amount of miles you can go? If you have no gas, how far can you go?
0.
0 miles. All right, tell me the upper boundary and how you got it, please.
900.
How'd you get it?
Because I multiplied
Talk
it.
loudly.
Because I multiplied it.
Multiplied what?
6 times 900. 6 times 150.
Okay, so he said, all right, if we have all these gallons of gas, we can go 6 miles per that. So we multiplied 6 times 150, and that was 900. So this says we can drive anywhere from 0 to 900. I don't know. Is that accurate? I don't know if that is. Can you drive 900 miles on one? I know 6 miles per gallon is correct. We did Google that. I don't know how much.
It's
it
accurate if
takes.
you have a 150 gallon tank, right?
Does a bus have 100?
That seems a large amount, but they are big. I don't know what it's on. I've never
Yeah.
had on empty.
Yeah.
You guys researched it?
Me neither. Well, we searched this, but now that I see that number, I'm like, maybe we didn't search that one. I don't know. I don't drive a bus. I could tell you that right now. I do not, but my husband does, and my kid thinks that every time we see a school bus, that's Daddy's school bus. So like when we drive to work, he's like, Daddy's school bus. I'm like, no, they're not all his, but he loves them. So this was a fun problem. So range had to do with the miles, okay? So that's a lot. There's a lot of thinking with these, but y'all are on the right track. So let's try one more. I'm going to help get you started. I'm going to help get you an equation, and I want you guys to go in and think about your boundaries. This is not accurate. I am not running a marathon, okay? I don't know why they're picking on me, but they said I am. And a marathon is 26.2 miles. That sounds miserable. Just sounds miserable. It's not for me. Not for me. But we'll pretend. This will be a pretend world. So I'm running a marathon. It's 26.2 miles. For each mile she runs, she burns 120 calories. Write a reasonable domain and range for this situation. First test, is it continuous or discrete? We're talking about distance again, right? Continuous. So I'm going to do a continuous setup. I'm going to put a C for continuous. I'm going to go ahead and just fill in my setup. X less than Y, less than. And then I think it really, really helps to make an equation. Okay? So For each mile, she burns 120 calories. What's our equation going to be? Y equals, I need a whole equation. 120x. Are y'all catching on? Whenever it says each or per or any kind of word like that, that's what you're going to put. That number and then x. Now, what is x going to represent? Each what? Read the problem. Miles. So this time, x represents the number of miles that I'm running. What does y represent?
This,
Calories.
The calories that I burn. Okay, there's your hint. So domain is going to talk about the boundaries on the miles. Range is going to talk the boundaries on the calories. Ready, set, go. Okay. Miles. Domain.
I got 0 and
26.2.
0 less than or equal. Did you put equal to? Yeah, because we can run exactly 0. And then we can run exactly, upper boundary is 26.2. So that's saying any number between 0 and 26.2 is what I can run. Okay? Now, calories. You kind of need, in these problems, you kind of want the domain first because that's going to help you figure out what numbers go here. If I ran 0 miles, then how many calories would I burn? 0. So your range is going to be dependent. It's your dependent variable on what that number is, your independent. If I ran 26.2,
314.
where'd you get that?
I multiplied 26.2 times 120.
120. So the most calories, 3,144. And again, we can do exactly those. So I think that these word problems are like the top level of difficulty with domain and range. I can do domain and range on graphs all day. But the word problems always kind of make me go like, whoa, 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 whoa. And I just go through my checklist. Is it discrete or continuous? What's my equation? What is my domain talking about? What is my range talking about? And then I can kind of reason through it. They literally call it reasonable domain and range. You see that word right there? Reasonable, reasonable. So that means in the story, what makes sense? What's possible? Okay, and so you got to think about what makes sense with that. So let's flip over. And I want you guys to try this graph. Save, don't do the words yet. We're going to do the words together. I just want you to do the domain and range. And then I want you to try this word problem. Okay, now remember the word problem. You have to go through the checklist. The word problem may not be continuous like we've done today, so you might want to look back to that. So try those. Graph first. And I want to write the words together. So this graph, continuous or discrete? Continuous because it is connected. Very good. All right, so my domain is going to look like this. Less than x, less than. Range will be less than y, less than. And let's fill in our boundaries. What was our leftmost boundary? -3. What kind of circle did I have?
open.
Open. So I just leave that. What about my rightmost boundary? 1. And it was a closed circle, so I have a or equal to. All right. What about our range? What was our lower boundary? -4. Do we equal to? Yes, because I got a closed circle and I've got touching graph right there. So I will equal to. What about my upper boundary? 0. Do we equal to? Right here, do we equal to? How do you know that it's a no? Okay, but what about right here?
We have to assume that's a close one.
You assume that's a close. If it's closed one time at that place, that's going to trump any open circle. So since it is touching right there, we are going to put an equal to right there. Even though this guy's open, we do have a place that it touches right there. So technically it does equal at that value, even if it's just at once. Okay, does that make sense? That's a little bit different. We good? Okay, so I want to write this in words. And again, you're going to see a star question that has to do with that. So let's write this in words. So we'll do the domain right now. I'm going to have to write kind of small. Actually, I'm going to put that up here so I have more room. Okay, our domain. This is saying I'm going to read this inequality, like cut off half of it for a second. What does this inequality say right now? What's another way you can say that? X is greater than -3. So we can say all numbers, I'm using number, I'm abbreviating with it. That's a pound sign, hashtag, whatever. It means numbers. All numbers greater than, but not equal to. So I'm just going to say greater than. -3. Okay. That's that side. Now what does this side say? X is what?
Are less than or equal to 1.
Not more than or equal to.
No, this one, the way this one is faced is X is less than or equal to. Because you're still reading it that way, yeah. So all numbers that are greater than -3 and less than or equal to what number? +1. Okay? Whew, that's a lot to write. I'm not going to make y'all do this a whole bunch of times because it's kind of annoying. Okay? I just want you to recognize if you get a multiple choice question, I want you to be able to interpret those words. It says the exact same thing that the inequality does. On your test, I want you to do the inequality because that is way less writing for you. But I just need you to understand that those are the same things. And if you're kind of confused, just do what I did. Cover up one side and just read the inequality. Okay? So let's look at this one. Let's look at the range. R for range. Right here. You okay writing? We good? Okay? All right, let's check this half. What does this say? Y is okay, if you read it this way, if you read it left to right, it says -4 is less than or equal to y. So if you do it backwards, it's y is greater than or equal to -4. So we'd say all numbers greater than or equal to, I'm going to abbreviate, -4. So all the numbers bigger than -4, but has to also be smaller than 0. Or take less than. That sounds more mathy. And less than or equal to 0. Woo! That was a lot. That was a lot. Okay.
So if I'm looking at the range, guys, and you have multiple choice of numbers that could maybe fit in the range. If I have the number 5, is 5 going to be inside the range?
+5.
No,
No.
Why not?
it has to be equal to or less than 0.
It has to be less than 0, then obviously greater than -4, right? So that's what they're saying, is the number has to fit in between there. So it's good that you can recognize that. So like maybe -2, is that true?
Yes.
That would be a number that would work. Okay, so that's what they're saying. We're trying to figure out what numbers are, make this work.
And it's a lot. And again, there's one on, let me jump to your Delta Math real quick and see if I can see it, because I was putting a bunch of STAR test questions in there. Just to show you like what I mean right here. This is a question on your Delta Math, so I'm not going to answer it right now. But if you look at this, it says, what is the range of this situation? And they wrote it out in words. Okay, so you just need to be able to interpret what that means. I think you can do it, especially if it's multiple choice. I don't foresee them doing a not multiple choice question where they wanted you to write all real numbers, blah, blah, blah. I think it would be more of a matching situation like this, but I just want you to be able to kind of follow. All right, what are we talking about? Again, keywords with these STAR questions is most of the time, not always, but most of the time they're only going to be talking about one. So they're going to put, this guy wants the range. They are going to put answer choices that are the domain. So don't get tripped up on those because you got to really interpret the problem and know what they're talking about, okay? So that's what we're going to work on as soon as we're done with this. Let's talk about this word problem. I saw you guys going through that. Had some conversations about, what are you doing?
I'm watching.
Oh, watching what?
I'm watching the screen.
It looks like you're looking at my Chromebook. I don't think there's anything on there.
It's on, right?
Reading my emails? Okay, so you're selling candy bars for the choir fundraiser. Each box has 20 candy bars total, and each candy bar costs $2. What's the reasonable domain and range? So remember, when we see these word problems, the first thing we want to ask, is it continuous or discrete? And I had to correct a lot of you guys on that, Okay, what's the answer? Continuous or discrete?
Discrete.
Why is it discrete?
Because you have a limited amount of candy bars.
Well, not necessarily because it's limited, because can you buy fractional amounts of candy bars?
No.
No, okay? We can only buy whole numbers of candy bars. So if you can't get all those decimals in between, it has to be discrete. So the way that you write your domain and range is going to be different. This is the squigglies. This is what we did last time, okay? So I'm going to go ahead and just set up squigglies there to help me. Now, I still think with word problems, having an equation is helpful. How much does each candy bar cost? So what is your equation going to be? Y equals 2x. Each bar. What is x going to be talking about? Candy bars. The number of candy bars. So that's going to go with our domain. What's the least amount of candy bars we can sell? 0. What's the next? 1. What's the next? Dot, dot, dot. What's the most? 20. And when you write discrete, I want you to get just a couple, like 3 numbers at the beginning so we can see the pattern. And then I'm good if you dot, dot, dot. I don't need you to write out all those numbers. But those are the only possibilities. We can't do decimals. So it's like 0 or 1 or 2 all the way up to 20. Okay? And that X is talking about my candy bars. Range, what does Y represent? Money. How much money we make. So we sell no candy bars. How much money do we make?
None.
0. We sell 1 candy bar. How much money do we make? 2. How do I know? They cost $2. 2 candy bars gets me dot, dot, dot. 20 candy bars gets me 40. And that's how you would write it right there. So a lot of you guys got the 0.20, 0.40 correct. You just have the incorrect notation. And so it's kind of tricky, but you got to reason through it and you got to think, can I have halvesies of these? Okay? Y'all want to take a quick brain break and then we'll finish this last problem? All right, we'll take a 3-minute brain break. Okay, this is a good problem. So we're going to start it. I like it. I do think last class and the way what we've done so far, you guys can do this problem. But I'm going to show you kind of 2 ways you can write it, okay? And that's just because there's an arrow on that. So let's just do it the plain old way we've been doing it. Is it continuous or discrete?
Continuous.
It's continuous, okay? So let's do our setup right here. Less than x, less than y, less than, okay? And let's do our boundaries. Can we put a boundary on the left side of this graph?
Yeah.
Yes, we can. And what is that boundary going to be at? 1, 2, 3, 4, -5.
Yeah.
Very good. But the circle is,
Whoa.
there's an arrow.
Open.
The circle is open, so I'm not going to put an equal to. Now, there's an arrow. You're going to see an arrow on your test, so I want you to know what to do with that. The arrow means it's going
Infinite.
to either positive or negative infinity. Now, when we talk about domain, we're talking about left to right. I understand this arrow is pointing down, but that is not going to mess with us right now because we're talking about right. Can I find a boundary on the right over here if there's an arrow? So this graph is going right forever. Right is which direction? Positive or negative?
Positive.
So forever in the positive direction is what symbol?
Good.
Positive infinity. So I can write it like that. Okay? Don't let the fact that the arrow is pointing down trip you up. When you're talking about domain, you're looking at, is it going right or left? And it is going to the right, and the right is positive. Now, the range. Now we look at the fact that it's pointing down. Can we put a bottom boundary on this graph because of that arrow? No. On the y, what is down forever? Negative infinity. That has to go first. Because it's the lowest. It's the most negative number, okay? Now, do we have an upper boundary?
Yes.
We do. Is that up there at 8? I haven't counted. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 8 right here, open circle, so we're good there. If you put this on your test, totally right, full points, good to go. I just want to show you another way that you could write this, and then we'll write it in words. Again, we'll get to where we can kind of do the shortcuts a little bit easier with different functions, but when you have a graph that is going off to positive or negative infinity, you can kind of leave that part off of the inequality. So here's just another option for you. I could also say, and let's just like talk about it in words right here. My boundary is at -5. My x boundary is at -5. But which way is the graph going from -5? It's going which direction on the x? On the x. It's going to the right forever. And so from -5, are the numbers to the right greater than that or less than that? If you're going to the right, are the numbers greater?
Greater.
So, and then they go on forever. So I also could write it like this. X values that are greater than -5. Okay, this means the exact same thing as the triple one that we did right here. Because basically, I can cut this little less than infinity off, and I can read it as, oh, I can have any x's that are just bigger than -5, because it just goes from -5 forever. So this is kind of a shorthand. Again, if you put the blue one on your test, you're going to get full points. But there is a case with infinities and negative infinities that you can write it a shorthand way, and that would involve a greater than. If you're not ready to go there, then just do it the way we've been doing it, okay? But I just wanted to show you either way. So in words, we could say that it's any number, all numbers greater than -5. That's how you would say that in words. There's no upper boundary. So it just goes from there forever. So you don't have to write that upper boundary on there. Okay? What about the range? Do we have an upper or a lower boundary on the range? We have an upper. We put an 8 up here. Okay? So our highest y value was 8, and then where did they go from there?
You just said all numbers less than 8.
Exactly. And you would write it like this. Y is less than 8. In words, all the numbers less than 8. Okay? Good job. All numbers less than 8. So again, it's blue answers would get all the points on the test. Perfect work. Okay? The pink answers are just kind of a shorter hand that you can use. The words are just interpreting what you wrote, but all of these are acceptable there. So I think there might be some Delta math problems that maybe kind of do this shorthand notation. So just as long as you can interpret it, you're good. So what we're going to work on now, and I'm probably going to set an alarm for like 10:15 so we can do that check for understanding, is there's a few more questions in Delta math. I know I kind of showed you some of those. That I want y'all to finish up. And you should be able to finish that entire assignment. I think I just put maybe 4 or 5 star questions. Yeah, 2.3 domain and range. So that's what we're doing there. Go back. Oh, back to home. These right here. So get your Chromebook out. And you're trying to do these 2.3. So they're just individuals. They're star questions. Do not just guess. Okay? Read the problem. Make sure you can do it. And then at 10:15, we're going to do a CFU.
Can I go to the bathroom?
Yes.